Now let's talk about identity matrix and zero matrix, okay? There are two types of special matrices. That's identity matrix and zero matrix. And here's important thing. Identity matrix must be square matrix, okay? Not any rectangular. It must be a square matrix. What does that mean? Number of rows and number of columns are equal. That's right. And one will be the element on main diagonal, okay? And I'll show you what that means, okay? Main diagonal. And zeros for others. That's identity matrix. So if I have I2, 2 is the subscript. What is the dimension of this matrix? What is dimension of this matrix? That's right, 2 by 2. How do you get extra 2? Because we know this is a square matrix from the name, right? It's identity matrix. I stands for that. And we have 2 as a dimension. That means number will be 2 by 2. Okay, so let's create 2 by 2 matrix. So start with number 1. And main diagonal means diagonal from this number 1, okay? So next one here, and that's it. And other numbers will be 0. So this is 2 by 2 identity matrix. Okay? Can you create I4? What is dimension for this? 4 by 4. Start with number 1, okay? Diagonally to the right from the first number diagonally, okay? And that's it. And there will be only 1. And other places, what's the element? 0. So let's put 0. 0, 0, 0. 0 here, 0, 0. 0, 0, 0 here. 0, 0, 0, 1. So that is called the identity matrix. And we will see why they put name as identity later, okay? Identity matrix. The other special matrix is zero matrix. Zero matrix can be any dimension. So it is written 3 by 2. So let's go by 3 by 2. 3 rows, right? 3 rows. 0, 0, 0, 3 rows. And 2 columns. So 2 columns. What is the element? All zeros, right? So that's called the zero matrix. Last one, zero matrix, 1 by 4. How many rows? 1 row. How many columns? 4 columns. So 0, 0, 0, 0. That's it. With the bracket, okay? Bracket is for the notation for matrix. All right, wake up. Question number 5. Scalar multiplication. Do you remember geometry class we talk about dilation, making bigger, smaller? What's scalar factor? Do you remember algebra 1 and 2? We talk about vertical stretch and shrink. What is a scalar factor? Yeah, those are the numbers, right? So we see the same thing here. Question number 5. Simplify each of the following matrices by distributing the scalar. So this is scalar and we are multiplying it. So you can just think simply, oh, distributive property, that works, okay? So let's multiply -2, same scalar for every element. All right, -6, -2 times 0 is 0. 2 negatives make positive, so that is 2. Next row, multiply by -2, 4. Next one, -10 and -8. So by using numbers in front of the matrix, we can do multiplication. So we can do all operations with this matrix as a tool. Can I multiply the variable then? determine what is X times matrix with A. And then I need to do X in front of this matrix, right? Can we do the operations? Yes, we can. So let's do the distributive property, okay? X times Y, XY. X times -1, -X. And the below, X times 0, 0. X times 3X, 3X squared. So we can do algebra with the matrix as a tool, okay? So we talk about multiplication with the scalar factor here. And can we do addition with the scalar factor here? Yes, right? Can you do last question? Have you seen T at the top? What was the meaning of T? Transpose of the matrix. What does that mean? Swap rows and columns, right? So you need to know the definition of the transpose matrix, and then you will do addition, okay? All right.